Okay, now we're going to have some fun. Section 11.4. The last section we kind of got a little preview about how to draw one of these given the equation. In this section we're going to learn how to write the equation given the graph. So you should have a template once again, and you should also have your graphing calc. Okay, so our job is to take a look at this lovely graph and figure out a way to write it is y equals, in sort of a form y equals a sine bx and a form of y equals a cos bx. So I'm going to give you a step-by-step process. So on the left side here I'm going to do sine, and then I'll do the whole thing again on the right using cosine. Okay, so basically what I want to do is figure out what I need to put in, and in this case there is going to be a phase shift, so I'm going to write a little more complex version of our general equation. It's not moved up or down, so I haven't put plus d on there. So that's my goal. If you remember, you always kind of want to go back to like just one round of a sine looks like what I just drew there on the board. So we're going to just step by step go through and figure out all the different pieces. I'll use some different colors to separate. So we're going to start easy. We're going to start with 1. So in order to figure out what the amplitude is, I think in this case it's pretty straightforward because you can just look up here and see it goes up 1, or I'm sorry, it goes up 2, down 2, so the amplitude in this case is 2. Now if it wasn't that straightforward, I do want to remind you that the amplitude is really just take the maximum minus the minimum and divide that by 2. So in this case the max was 2 minus the min is negative 2, so minus and minus would be a plus, so 2 plus 2 is 4, and 4 divided by 2 is 2. So you can always do that if you need to. Okay, so step 1, easy, usually find the amplitude, feel like you're off and running. Okay, step 2, identify one cycle that begins and ends at y equals 0. And does kind of what we're talking about, one round of sine, sort of the traditional looking sine. And then you want to determine the endpoints of that interval. Okay, now the one thing you do want to do is you want to pick one round that is basically the closest you can kind of get to the origin. So when I look up here, my one round, because I want to get the origin involved and be close but not move too far off the origin, would be this right here. Okay, so what are the endpoints then? I start at negative 2 pi over 3 and I end at positive 2 pi over 3. So I'm going to go ahead and I'm going to write those endpoints down and spell determine correctly. So the endpoints then go from negative 2 pi over 3 to 2 pi over 3. Now, for notation purposes, I'm going to refer to this as going from x naught, sort of the beginning position, to x sub 1. Okay, ready for step 3. So step 3 now, we are going to figure out the period, like how long it takes this thing to do its thing once. So the period then, hopefully we're starting to get this in our head, is equal to 2 pi over b. And in the end, what I really need is I need to know what b is, because I need to put b in the equation. So like I've already got what a is, now I'm in the process of trying to figure out what b is. So the period is how long does it take, if I'm walking on the x-axis, how long does it take, whoops, let me get this back in line here. How long do I have to walk to see one complete cycle of sine? So this right here really is the length of the period for this particular graph. And so probably the easiest way to figure this out is just to take the thing in the second position minus the thing in the first, because that's how you're going to figure out that distance measurement. So then this is going to be equal to 2 pi over 3 minus negative 2 pi over 3. So 2 pi over b then is equal to, and if you don't like fractions, just put the fractions in your calc and bring the pi along for the ride. So it's really 2/3 plus 2/3, also known as 4/3. So 4 over 3 pi. So now I need to solve this thing for b, and I'm going to use cross multiplication to do that. So I get 4 pi, when I go this way, 4 pi times b is equal to 2 pi times 3, which would be equal to 6 pi. I can divide the pi's off both sides, and then to get this solved for b, I'm going to divide both sides by 4. So as it turns out, it's a little weird, but for this one, b is equal to 3/2. Okay, we're getting there. We know what A is, now we know what B is, so now we just need to figure out what C is, the phase shift. So, to figure out what C is, C is pretty straightforward. It is the opposite of the lower endpoint. So the lower endpoint would be this x sub 0. So C then is equal to the opposite of x sub 0. So in this particular case then, x sub 0 is negative 2 pi over 3, so the opposite of negative 2 pi over 3 is just, negative 2 pi over 3 is just 2 pi over 3. And hopefully this makes some sense, because if it's a positive number, then it goes to the left. If it's negative, it goes to the right. Okay, we're almost there. So step 5 then is just to fill the blanks in and write your equation. So step 5, write equation. And like anything, the more you practice, the easier this will get. So I have y equals a sine b x plus c. And so I'm just going to put the numbers in. So y is equal to 2 sine b was 3/2, and then x plus 2 pi over 3. Now I'm going to go ahead and distribute the 3/2. I don't necessarily have to, but sometimes it's nice to just clean it up. So y equals 2 sine, I'm going to take 3/2 times x, so that would be 3/2 x, plus, when I take 3/2 times 2/3, that's just 1, and so that turns out to be pi. And then the last thing I would always suggest you do is check it on your calc. So check on calc. And so put this into your y equals, and then set the window so that you see exactly what's on the paper here. So I'm going to set my window from negative 2 pi over 3 all the way to 2 pi, and it should look the same. So if I go over to my calc, I've already put this into my calculator, and so now I'm just going to start. Usually it's a good idea to start with the zoom trig just to kind of get it in the right zone. And I'm going to go to my window, and I'm going to type in negative 2 pi over 3, negative 2, negative 2 pi over 3 is my starting point, and my max point I want to go to is 2 pi, so 2 pi. And if you look on the grid, the little tick marks on this thing are counting by pi over 3, so I'm actually going to type it in so my tick marks look like what's on my paper. And now I'm going to hit graph, and you'll notice if you hold up your paper that this is exactly what it looks like on the paper. Now oftentimes you're going to do this and it's going to come out and the graph's not going to look like what's on the paper, so hopefully that might give you a chance to say, ooh, wait a minute, something has to be slightly changed. And hang in there. I know this is kind of tricky, but with practice, as I said, you'll get better at it. Okay, so the other thing is to graph this for cosine. So y equals a cos b x. And so some of these things are just going to end up being exactly the same. So I'm just going to go ahead and zip on down. So the amplitude for cosine is going to be exactly the same. It's just going up the same amount. Okay, as far as identifying one cycle, so in this case we're going to want a cycle that is a cosine cycle. So I'm going to go on up here and I'm going to look at this graph and I'm going to find the closest one round of cosine I can find that's near the origin. So that would be this guy right here. And I need to identify these endpoints, and I know they're fractions and they're maybe a little bit yucky, but you can do it. Okay, so to determine the endpoints here then, this guy is going from negative pi over 3 to pi. Okay, I'm going to step through all the same process here again. So now I'm going to come down here and I'm going to figure out what the period is. Same way I did this on the other one. So the period is equal to 2 pi over b, and remember that's just the length of one cycle, so it's going to be sort of take the right endpoint and subtract the left endpoint because that's a distance. So I have pi minus negative pi over 3, and if you don't like fractions, use your calc, put a 1 in plus a third. Okay, so that means 2 pi over b is equal to 4/3 pi, 4 pi over 3, and I would cross multiply here and I find out that b is 3/2, and this should not be surprising because as far as the frequency period are exactly the same. We're just labeling them. We're using sine to call it a sine graph and cosine to call it a cosine graph. Okay, now the phase shift is going to be different because we're talking about a cosine curve instead. So I'm going to do the exact same thing again, and basically C is just going to be the opposite of my lower end of the interval I've picked out up here, and in this case it's negative pi over 3. So C then is going to be equal to the opposite of negative pi over 3, which is pi over 3. Okay, last step, same as what we did before, is to write the equation. So y equals a cos bx plus c. So y is equal to, my a is 2, cosine, my b again is 3/2, and then this time I have x plus pi over 3. Now, if I distribute this, y equals 2 cos 3/2 x. If I take 3 over 2 times 1 over 3, I get 3 over 6, which is a half, plus pi over 2. And once again, I would suggest you check this on the calc. I'm not going to take the time here, but you could type this in on line y2 and see if this produces the same graph, and it should. So check on the calc. Now, one thing I do want to make a point of here is just to notice, like, what really is the difference between sine and cosine? The difference is seen right here, plus pi over 2. So the difference really is just a phase shift. So I'm going to take one moment to take a look at that. So you notice this just, everything, the only thing that changed here is instead of plus pi, that was plus pi over 2. So let's come back here and hit my y equals. And I am going to type in sine x. Okay, so based on what we just saw there, if I were to type in cos x, and I'm going to go ahead and type in minus pi over 2, and I'm going to leave you to think about this a little bit. And I'm going to go ahead and put the little, like as I like to call it, roll of toilet paper, so it'll bring a little round ball trailed with a or some, oh, there we go. Okay, so that you can see this, hopefully it's going to be one on top of the other one. And so I'm going to go ahead and hit graph here. And you will see that just by putting that phase shift in, I'm actually getting the exact same curve. And so you might want to actually like look at y equals sine x, y equals cos x, and look at them and see like, well, what's up with that? Does this make sense? Maybe try changing this to x plus pi over 2 and see how that looks. Does it work? Does it not work? We can talk more about this in class. Okay, so I realize this is, a process, but if you really just go through the step-by-step process, I swear you can do this, as well as with a little help from your calc of checking it after the fact. So if you flip the paper over, there's another one, and the directions would be to do precisely the same thing. So I would suggest you stop the video and give that a try, and when you're ready, turn the video on. I have my scanned solution on the next page, which I'm just going to run down that fast. Okay, so I'm not going to go as nitty-gritty into this as I did on the one I practiced for practice, but hopefully, if nothing else, you got yourself an amplitude, something of a starting point. So the amplitude in this case is 2. The round of sine that I used, if you look here, I used from negative pi over 3 to 5 pi over 3. Now you noticed when I had to do cosine over here, I had no choice but I couldn't cross over the origin, so I picked this right here as my interval to get one round of cosine. Okay, if you drop down, you can see I did the exact same thing. I used period equals 2 pi over b. I figured out the length of getting one cycle, and it turned out that b is equal to 1. So what does that really tell me? It tells me that this thing gets its job done, one round of it, whether it's cosine or sine, it does it in 2 pi, which is actually something you could see here, because this is from negative pi over 3 to positive 5 pi over 3, which would be 6 pi over 3, this length, which is 2 pi. So sometimes you might not have to do this kind of gnarly calculation if you can just realize, oh, it did its thing in 2 pi. It's not going to happen that often, though. Okay, and then dropping down, you'll notice what I did. I just took the opposite of my lower endpoint for my phase shift, and then I went ahead and I plugged the numbers right into the position. Now in this case I didn't do any distributing because b was equal to 1. And just to kind of reinforce what I was saying before, you'll notice if you take this y equals x plus pi over 3 and do the same thing we did before, the minus pi over 2, really all this is if I get this one and understand the phase shift with cosine, I can get to this one without having to go through all the steps. Okay, if you head on over to Math Excel for School, you can there's a little online homework practice to try to work with this a little bit more.